Okay, gentlemen, welcome to your first lesson of the next unit. We're going to do a lot of graphing in this one, and we're going to be discussing equations of lines, rearranging equations, and plotting coordinates on a grid. So, to get started, you should be on your first page here, and our first task is going to be about isolating variables. And we saw this a little bit earlier in the year, and now we're going to apply some of those skills that we learned. So the first one we're going to talk about isolating y in the following equations. What that means is you're getting y by itself, so you're looking at everything that's near the y and removing it. So you're going to start by removing whole terms first. So in this case, anything that's near the y, any terms that are there are going to be moved to the other side, and when that whole term gets moved to the other side, just remember that the sign changes. So this becomes a positive 2x, and you have a y on this side. And that's all it is. You're done with that one. Okay, we'll try the next one. We have our y here. We need to remove the terms that are near it. So this term is going to move over to the other side of the equal sign, and it becomes a negative 3x. The y stays over here, and you've isolated that y. Okay, we'll do a couple more here. In the next one, there's a couple more terms. Every term that's not a y has to go over to the other side. So this 2 is going to go over, and this negative x is going to go over. So the negative x actually becomes a positive x, and the positive 2 becomes a negative 2, and you're still left with the y on this side. I'm going to do one more as a practice. You're going to take every term that's not the y and move it to the other side of the equal sign. So this value comes onto the other side, so it becomes 25 minus x, and you're left with 5y on this side. But you're not done at this step. You still have to do one more calculation, and that means getting y by itself requires you to divide by that 5 here. If you do that to one term, you have to do it to every other term within the equation. So what you're going to be ending up left with is these 5's canceling each other out, or just a y. 25 divided by 5 is 5, and negative x over 5 just gets left as negative x over 5. Okay, so what I'm going to do right now is I'm going to pause this video. I'm going to let you guys try the next couple here, these next 4, and when it becomes unpaused, immediately on your screen you're going to see answers. So I suggest you pause your video at the same time, try these 4, and then press play again. So now that we're done, each of these 4, I'm just going to run through them really quick. Okay, just isolating different y values in each one by bringing over full terms at a time. So negative 6 becomes positive 6, positive 8 becomes negative 8, and then you're dividing by 2 each time. In this case, you can divide perfectly these whole numbers. 6 and 2 would become 3, and 8 and 2 would become 4. That negative sign still stays there. Sometimes they don't divide perfectly. Sometimes you have x over 3 and you have to leave it as a fraction. And down here specifically, when you divide every term by 5, you're just going to be left with a fraction. Doesn't look pretty, but you have to keep it as is. Okay, not going to turn this fraction into a mixed number, just leave it as an improper fraction. And then in the bottom one, question H, you're dividing by 4 in each term. 4 happens to divide into 16, so it becomes negative 4. Doesn't divide into negative 3, so you have to leave that as a fraction. Okay, so we're going to keep moving along down to the next part. So we're going to talk about using linear relations. So just to get our vocabulary right here, this is called a linear relation, and we'll talk about why it's called linear a little bit later on. Okay, so when we talk about a linear relation, it's an equation that looks like this. You have a y value on one side, you have an x multiplied with a number, and you have a constant by itself. Okay, so all you're doing is you're substituting your x values into the equation and coming up with a y value. Earlier on in your younger years, you would have done something that had to do with an input and output machine. So your input part would be your x value, inputted into the equation. Your output would be what gets calculated in the end. Okay, so for the first one, and I won't do them for each one, but the first one would be 2 times negative 2 plus 3 or negative 4 plus 3 would be negative 1. So this becomes a negative 1. And then you're going to try substituting negative 1 in from this part. Negative 1 plus 3. So negative 2 plus 3 would be positive 1. 2 times 0 plus 3. So 0, when you multiply it with 2, plus 3 would be 3. So we have a 3 here. And you have a 2 times 1 plus 3. So 2 plus 3 would be 5. And then 2 times 2, which is 4, plus 3 would be 7. So you can also have a look here. When something is a linear relation, whenever you substitute constant values in here, or values that grow consecutively, that you're going to end up getting a pattern within your y values. You're going to be growing by the same amount. So it's increasing by 2 and increasing by 2 and increasing by 2 and increasing by 2 each time. That's just one of the characteristics of a linear relation. When you input an x value, your y values that come out will form a pattern. So we'll do the next one together. Actually, you know what? We're going to pause it. I'm going to pause it. I want you to try it and see if you come up with the same numbers as me. So I'm going to press pause. I want you to press pause as well, because when you let go, all the answers are going to be on the screen. So go ahead. So at this point, when we've already got 3 values calculated in here, we start to see a pattern emerge. Negative 6, negative 5, negative 4. The next value is going to be negative 3, negative 2. And the reason being is because the x values change by the same amount as well. So these go by 3 and 3 and 3 and 3. So the y values are going to change by the same amount as well in a linear relation. Okay, so all this is substituting and finding values as an answer. In the next one, to be able to do this, you can't really substitute your value into your equation, because then you still have an x value on this side. So it's easier to isolate your y value first. So just on the side, 5x minus y equals 4. In every other question that we've had, the y value is positive. So what we're going to do, instead of putting the x over here because we were so used to that, we're actually going to put the y value on this side. And we're going to move the 4 over to the other side. So we actually have 5x minus 4 equals positive y. And that way our answer, or what do we get for our value of y, is the positive value of what our solution is here. So we're going to use this expression here to help calculate our output values, our y values. So in our first one, it's going to be 5 times negative 2 minus 4. So 5 times negative 2 is negative 10, minus 4 is negative 14. 5 times negative 1 minus 4, so negative 5 minus 4 is negative 9. 5 times 0 minus 4 equals negative 4. So you can start to see a pattern emerge here. Negative 9, negative 4. We'll do another one. 5 times 1 minus 4, so 5 minus 4 equals 1. And 5 times 2 is 10, minus 4 equals 6. So you can see that these grow by a value of 5 each time. Okay, and this is going to be a characteristic that we're going to use later to help prove whether or not a relation is linear. Okay, so a relation is the connection between these x and y values. Okay, moving on to the next one, I'm going to let you guys do this by yourself. I'm going to press pause. I want you to do the same thing because in about 10 seconds all the answers are going to be on the screen. Okay, so go ahead, press pause. I will too, and we'll see what you end up with. So once you do all your calculations, you're going to end up with the values 12, 11, 10, 9, and 8. So 12, 11, 10, 9, and 8. So just more proof that this is a linear relation because these y values and these x values change at the same rate. So this one goes up by 2, and this one, because this goes up by a constant amount, this one's going to go up by a constant amount as well. Just one thing to highlight is that when you are substituting a value, this negative 4 goes in for just the x. So what you're left with is a negative 4 inside the brackets and a negative value outside the brackets. And that's the importance of substituting values in a set of brackets to help preserve that negative value. Okay, moving down the page a little bit further. Okay, we have our next question here is graph the following line using a table of values. So you can choose whatever x values or whatever input values you'd like. Usually it's nice to choose something that is on both sides of 0. So if I put 0 right in the middle, and I put negative 2 here, and I put negative 4 here, I'll put 2 here and 4 here on this side. It's good to go up by the same amount or change by the same amount in your x values, so that your y values, you can see they're going to change by the same amount too. It doesn't hurt and it doesn't change anything if you choose an x value of 9 and then 7 and then 0 and then 2. It just makes it a little bit more difficult and less predictable when you're going to graph it. Okay, so for the first one, 2 times negative 4 is negative 8, minus 3 is negative 11. 2 times negative 2 is negative 4, minus 3 is negative 7. 2 times 0 is 0, minus 3. You see the pattern emerging right now, moving by 4, by 4, by 4. The next one's probably going to be 1. So 2 times 2 is 4, minus 3 would be the 1. And again, so this is going up by 4, the next one should be 5. So 2 times 4 is 8, minus 3 is a 5. So these become your coordinates, a negative 4 and a negative 11, and negative 2 and negative 7, and so on and so forth. And you're going to plot those coordinates on your graph. Okay? So just looking at your coordinates, negative 4 and negative 11. So negative 4 is here, down to negative 11, all the way down here. Okay, negative 2 and negative 7. So negative 2 down to negative 7. 0 and negative 3. So 0, negative 3. Next one is 2 and 1. So 2 and 1 goes here. And the next one is 4 and 5. So 4 on the x and 5 on the y value. Okay. And what's going to end up happening is that you start to see a series of dots. And because it's called a linear relation, it has the word line in it. You can actually connect all these dots once they're graphed with a straight line. All those dots should lie along a straight line and you get a linear relation. Okay. All right, so we'll keep going down the page to the next one. What you're going to have to do here first is isolate the y. So you're going to have 2y, oops. Scroll back down here. You're going to have 2y equals negative 4x plus 6, or y equals negative 4x over 2 plus 6 over 2, or y equals negative 2x plus 3. Okay, so once we get our y all by itself and everything else simplified on the other side of the equal sign, we can start choosing values to substitute in. So why don't we do the same thing again? We'll put 0 in the middle. This time we can go negative 1, negative 2 up here, 1, and 2 is our values for x. Again, it doesn't really matter, it just makes it easier if you choose them so that they go up by consistent values. Okay? So at this point I'm going to pause and I'm going to let you try it, plot the points and connect the dots and see if you get a straight line. So go ahead. Okay, so your finished product should look something like this. And this time the line is actually going downhill here. Okay. All right. Sometimes when you graph these lines, what you can do as well to make your graph complete, you can label them as the equation that's given. So y equals negative 2x plus 3. Okay. All right, moving down a little bit further. I'm going to try one more. I'm going to let you do this one right from the beginning all by yourself. Isolate the y first. Use some values in your table. We may not end up with the same ones, but our lines should be in the same place. Okay, so do your best. Good luck. Press pause, come back when you're done. Okay, so depending on what values you chose, your points that you plotted would end up anywhere along this line. Okay, regardless, your line will be drawn in the same direction and cover every bit of the same space of this graph as mine. Okay, all right, so that's plotting your coordinates. We're going to move on to something a little bit different now. Okay, it's about reading the graphs and understanding a different part of the graph with a couple definitions. So you have a definition of x-intercept. An x-intercept is where, x-intercept is where the line crosses the x-axis. Okay, and the y-intercept is where the line crosses the, guess what it is? The y-axis. Okay, so pretty straightforward. You're just identifying the coordinates of where the x-intercept is. Okay, so depending on how we decide to write these, I'll give you two options. Is state the x and y intercepts of the following. Okay, so for the first one, I'm going to write it out like this. X-intercept equals 2. Y-intercept equals 1. The coordinates for the x-intercept would be 2, 0, and the coordinates for the y-intercept would be 0, 1. Okay, so that's stating both intercepts. We'll do it once more over here. So in this case, x-intercept is 2 for a coordinate of 2, 0, and the y-intercept is equal to -4 for a coordinate of 0, -4. Okay, I just want you to keep in mind a little pattern that's evolving here a little bit about what the y-intercept coordinate looks like each time you write it down and what the x-intercept coordinate looks like each time you write it down. We'll scroll down once more down here. Got a couple other ones. The x-intercept here is 0, crosses at 0. The coordinate here is actually 0, 0. The y-intercept, where it crosses the y-axis, is in the same spot, 0, so your coordinate is 0, 0. Okay, and the final one, x-intercept equals, well, there is none. Okay, the y-intercept is +3 for a coordinate of 0 and 3. Okay, and we'll talk about this type of line a little bit later. We'll refer to it as a horizontal line, but for now we're going to move down a little bit further. Okay, so how to calculate the x-intercepts without looking at a graph. Okay, so this is without a graph. The x-intercept, set your y value equal to 0 and solve. Okay, and the reason why we do that, if you looked at the pattern above, every time we saw an x-intercept, there's one coordinate that we're going to know for sure. Every time the line crosses the x-axis, the y value is going to be 0. So if we know one part of that coordinate, we can solve for the other. Okay, and the same thing for the y-intercept. We're going to set the x value equal to 0 and solve. Okay, so for the next couple questions, we're going to be solving for x and y coordinates. I'm going to do 2 with you. I'm going to ask you to do 2 on your own. So find the x and y coordinates of the following. We'll start over here. X-intercept. Okay, this means that y equals 0. So you have 3x minus 4 times 0 equals 12. Or you have 3x equals 12, and you divide by 3 on each side, so you get x equals 4. For the y-intercept, Okay, your x value is going to be 0. So this time we have 3 times 0 minus 4y equals 12. So we're left with negative 4y equal to 12. And divide by negative 4 on each side, we end up with negative 3 on this side. Okay, so instead of actually doing the next one, I'm going to ask you guys to press pause, try it yourself. I'm going to press pause, and when you unpause it, the answer will be there. So give it a try, press pause now. Okay, so the answers that you should get for the next two are x equals 3 and y equals negative 2. You can pause the screen again if you need to copy that down. I'm going to ask you to pause the screen anyways to try the next question here. So go ahead. So there you go, answers for the next ones. Negative 8 for x and y equals 16. This first one's a little bit different because the y value is already by itself over here. So you're going to have to remove something from the x side of the equal sign. Alright, moving down, one more, last one. Pause the screen, try it yourself. Go ahead. Okay, and there you have it, your last two. You have 15 for x and negative 5 for y. So that's it for the lesson. I need you guys to do the homework for this lesson 1. And then I want you guys to be ready for your test on Monday. So good luck, do your best, and we'll see you guys on Monday.